बिस्मिल्लाहिर्रहमानिर्रहीम। हेलो एवरीवन, वेलकम बैक टू दी अनदर वीडियो। आज की इस वीडियो में हमने वीके मेहता का सेकंड चैप्टर जो है डीसी सर्किट उसके एमसीक्यू नंबर 81 से लेकर एमसीक्यू नंबर 90 तक आज की इस वीडियो में हमने कवर करना है। सो एमसीक्यू नंबर 81, इन द सर्किट शोन इन फिगर 2.56 a battery of okay so in this circuit of EMF 10 volt and negligible internal resistance is connected across two resistance of 500 ohm in series. A voltmeter of 1000 ohm resistance is connected across one resistance. What is the reading of the voltmeter? Okay, so you need to find the reading of the voltmeter. Okay, it means that we will need to find the voltage across this. Okay, so as we know that we will apply the voltage divider rule over here. So voltage across this branch will be equal to the source voltage time the resistance, this resistance. Okay, so over here we will need to find the equivalent resistance as both resistance are connected in parallel. तो ये क्या हो जाएगा 500 times 1000 divided by 1500 हो जाएगा डिवाइड बाय सम ऑफ बोथ रेजिस्टेंस। तो सम ऑफ बोथ रेजिस्टेंस आपका ये हो जाएगा so this will be equal to 5 divided by 1500 over here. You will also this will become divided by 1500. So this 1500 will cancel by this 1500. Now you will add these two numbers. So if you add these two numbers, you will get this will become 0057. You will get this. Okay, so these two zero will cancel by these two zero. 5 times 1 is 5, 0 0 0 0. Over here 5 times 1 is 5, 5 times 1 is 5, 5 times 5 is 25, 5 times 2 is 10, 0 0 0, 5 times 2 is 10, 5 times 3 is 15. Okay, now you will divide these two numbers. So we did a mistake in over here. Actually, if you multiply these two numbers, you will get 750,000. Okay, so this will come over here. So 750,000 and 500,000, you will to add these two numbers, then you will get over here you will get divide by you will need to add these two numbers. Okay, so you will get 0 0 0, then over here you will get 0 7 5, and 7 plus 5 is equal to, so these four zeros will cancel out by these four zeros. Now 125 and 500, so if you multiply 125 by 4, so you will get 500. Okay, so your VB will be equal to 4 volt. So it means that 4 volt will appear across this. So option A will be the correct answer. Okay, next MCQs is MCQ number 82, that is voltmeter V1 and V2 are connected in series across a DC line. The voltmeter V1 read 80 volt and has a per volt resistance of 200 ohm, while V2 has a total resistance of 82 kilo ohm. The line voltage will be equal to, so we will need to find the line voltage. Voltmeter V1 is connected in series with voltmeter V2. Okay, across the DC line. Okay, so the voltmeter V1 read 80 volt and has per volt resistance of 200 ohm. So it means that internal resistance of this voltmeter will be equal to 200 times 80, so that will give you the total resistance will be equal to 16,000 ohm. Okay, while V2 has a total resistance of 32 kilo ohm. Okay, the line voltage will be equal to, so we need to find the total voltage. Okay, So over here we have 80 volt, and over here we need to find that. So this is the source voltage. Okay, the current will remain same in both distance. So okay, over here we will need to find the line voltage. So line voltage, it means that we will need to find this voltage. Okay, so we will apply the voltage divider rule. Okay, so voltage divider rule means that voltage across this V1, that is 80 volt, that will be equal to the resistance across this, that is 16 kilo ohm. Okay, times the source voltage, which is the line voltage in this case, divided by 16 kilo ohm, sum of all voltage, sum of all the resistances, that is this one. Okay, इसको दोनों को ऐड कर लो तो इससे हमारे पास क्या आ जाएगा, 48 किलो ओम आ जाएगा. Okay, this kilo ohm will cancel by this kilo ohm. So now 4 times 4 is 16, 4 times 1 is 4, 4 times 2 is 8, 4 times 1 is 4, 4 times 3 is 12. So your V will be equal to 3 times 80, that is equal to 240. Okay, volt. So in this case, option D will be the correct answer. Okay, next MCQ is MCQ number 83. That is figure 2.57 show a part of the closed circuit. The potential difference between point A and B is equal to. So we will need to find the potential difference between A and B. So your potential difference between point A and B will be equal to 3 times 6 is equal to 18. अच्छा, this is the dissipating. Okay, ये नेगेटिव पॉजिटिव हो जाएगा. अब ये भी ड्रॉप हो रहा है तो ये भी आपने यहाँ पे लिखना है. यहाँ पे भी ड्रॉप हो जाएगा. तो दिस विल बिकम 3 times 3 is 9. यहाँ पे राइज हो रहा है -6 हो जाएगा. सो योर वी ए बी दैट्स विल बी इक्वल टू 8 times 8 8 18 plus 8, that's equal to 26. 26 plus 9, that's equal to 25. 35. 35 minus 6 is equal to 29. So 29 volt, option D will be the correct answer. Okay, next MCQ is MCQ number 84. That is, in the Wheatstone bridge shown in figure 2.58, P is equal to 9 ohm. This is 9 ohm, this is 11 ohm, this is 4 ohm, and this is 6 ohm. How much resistance must be put in parallel to resistance S to balance the bridge? Okay, so if you want to, we will apply the balance bridge formula over here. So we will need to find this resistance R. Okay, okay, so first of all we need to find this equivalent resistance. That's equal to 6R divided by 6 plus R. This is my this resistance. Now you will multiply these two, the opposite of these two, like you will multiply it by 9, and that will be equal to 11 times 4, which will be equal to 44. 44 divided by 9 हो जाएगा. ये 6 भी उस साइड पे आ जाएगा. So here you will get R divided by 6 plus R. So 44, 6 times 9 is equal to, इससे क्या आता है 54. So 44 divided by 54. Now you will do the cross multiplication. So 44 times 6 will be equal to plus 44 R हो जाएगा. That will be equal to 54 R. So now your 54 R minus 44 R will give you 10 R. That will be equal to 264. So 264 divided by 10 will be equal to 26.4. So your R value will be equal to 26.4. Option B will be the correct answer. Okay, next MCQ, MCQ number 85. That is, a galvanometer together with an unknown resistor in series is connected across two identical batteries, each of 1.5 volt. When the batteries are connected in series, the galvanometer record a current of 1 ampere, and when the batteries are connected in parallel, the current is 0.6 ampere. What is the internal resistance of each battery? So over here you will have these two figures. Okay, so we will make an equation. Okay, so the current is I ampere, so voltage across this small r will be equal to 1 volt, R volt, and voltage across this will be equal to R volt. Okay, so this is dropping. Okay, like if you take it like this, so this should be rising, this is rising, this is dropping, this is dropping. So 1.5 plus 1.5 will give you 3. That should be equal to current is 1 ampere. So you will add all these 3. That should be 2R small r plus capital R. For this is 1.5 volt and this is 1.5 volt. So voltage across this will remain same. So over here, this current in this branch will be equal to 0.3 and current in this branch will also be equal to 0.3. Okay. So if you want to find the voltage, okay, so this is rising, this is dropping, this is dropping. So 1.5 volt, that should be equal to 0.3 times R plus 0.6 times capital R. So you will find the value of R from this equation. That should be equal to 3 minus 2R. So over here you will substitute the value. That should be equal to 0.3 small r plus 0.6 capital R is 3 minus 2 small r. So over here 1.5, that should be equal to 0.3 small r plus 0.6 times 3, that's equal to 1.8 minus 0.6 times 2, that's equal to 1.2 small r. So इसको आप सिंप्लीफाई कर लो. तो ये इस साइड पे आ जाएगा 0.3 आ जाएगा, माइनस 0.3 इससे आ जाएगा और इससे नेगेटिव 0.9 आ जाएगा. So this point will cancel with this point, this r negative sign will cancel with this negative sign. So your r will be equal to 3 divided by 9, which is equal to 1 divided by 3, which is equal to 0.333. So option C will be the correct answer. Okay, next MCQ is MCQ number 86. 6 equal resistance each of 2 ohm are connected as shown in figure 2.59. The resistance between any two corners is, so we need to find the resistance between any two corners. So let's find the resistance between these two corners. So over here we will need to find this, this is in delta, so we will need to find the equivalent resistance. So this equivalent resistance will be equal to these two, that's equal to 4 divided by summation of all, that's equal to 6. So 2 divided by 3, 2 divided by 3 this one, and same 2 divided by 3 will also come over here, same 2 divided by 3 will also come over here. So now this 2 divided by 3 is in series with this 2, so that's equal to, that will give you 8 divided by 3. So and these two are in also in series, so these two will also give you 8 divided by 3. So your figure will look like this: A, B, this will be 2 ohm resistance, okay, and over here you will get the 2 divided by 3. So from this you will get the two branches, one is 8 divided by 3, okay, and over here you will also get the 8 divided by 3. So you will join these two branches over here. So these two are parallel with each other. So from this you will get the one resistance, that will be equal to 4 divided by 3. So 4 divided by 3 is in series with this, so that will give you 6 divided by 3. So 6 divided by 3 will be in series in parallel with this, and 6 divided by 3 will give you 2 ohm resistance. So this as a whole will give you 2 ohm resistance. So both are in parallel and both have the same resistance, so the equivalent resistance will be equal to 1 ohm. So option A will be the correct answer. Okay, next MCQ is MCQ number 87. Resistance 1 ohm, 2 ohm and 3 ohm are connected in the form of triangle. If SL of EMF 1.5 volt and negligible internal resistance is connected across 3 ohm, the current through this resistance is, so we have triangle, okay, and in triangle we have 3 resistance. This is 1 ohm, this is 2 ohm, this is 3 ohm. If SL of EMF 1.5 volt and negligible internal resistance is connected across 3 ohm resistance, the current through this resistance will be equal to, so the current through this resistance will be equal to, we need to find this current. Okay, so now in this case the current, as we will apply the ohm law, that is V divided by R, voltage across this resistance is 1.5 volt and resistance is 3, so that will be equal to 0.5. so option B will be the correct answer. Okay, next MCQ is MCQ number 88. That is the current in 2 ohm resistor shown in figure 2.60 is, so we need to find the current in this resistor. Okay, we have the same voltage in both resistors. Okay, so voltage across this V1, the upper voltage, the upper branch voltage is equal to the lower branch voltage. So the so in this case the current will be I1 and resistance will be equal to 12 ohm. Both are connected in series. In this case, the current will be equal to I2 and resistance will be equal to 30 ohm. So now you have I1 and I2. Okay, like 12 I1 is equal to 30 I2. Now you have this current 1.4 ampere, that's equal to the addition of I1 plus I2. So we will need to find the current I1. Okay, so we are interested in I1, so you will substitute the value of I2. I2 will be equal to 12 divided by 30 I1, so you will substitute that value over here. So 1.4 will be equal to I1 plus I2, that's equal to 12 divided by 30 I1. so यहाँ पे आपके इससे आपके पास आ जाएगा 5I1 plus 2I1 divided by 5. So over here 1.5 will be equal to 7I1 divided by 5. So 7, so your I1 will be equal to 1 ampere. So option D will be the correct answer. Okay, second last MCQs of this class is 89. That is a wire has a resistance of 6 ohm. It is bent in the form of an equilateral triangle. The effective resistance between any two corners of the triangle is, okay, we have a wire that is 6 ohm. So it is bent in the form of equilateral triangle, means that all sides will be equal to each other. So if all sides equal to each other, then the effective resistance between any two corners of the triangle will be equal to, so let's suppose this is my A corner and this is my B corner, and we'll need to find the equal resistance. So this will be 2 ohm, this will be 2 ohm, this will be 2 ohm. So over here will have parallel combination of 2 ohm and 4 ohm. So this will be 2, this will be 4 divided by 6 हो जाएगा. So 2 times 1 is 2, 2 times 3 is 6. So 4 divided by 3, option C will be the correct answer. Okay, next MCQ is MCQ number 90. A charge of 10 millicoulomb flow through a cross section 2.5 millimeter square, 2.5 mm square, normally in 2 seconds. The current is, okay, so we need to find the current, and current is equal to the charge per unit time. Okay, so over here the charge is given to me. Okay, and area is given to me, time is also given to me. So this area is given to you just for confusion. Okay, so you will not be so this will be 10 times 10 power minus 3 हो जाएगा, कूलम डिवाइड बाय 2 सेकंड हो जाएगा. So this will be equal to 5 milliampere हो जाएगा. Okay, this will be your current. So option B will be the correct answer. Okay, so this is the end of this video. If you have any confusion in any MCQ, then please put that confusion in the comment section. Thanks for watching. Allah Hafiz.